Welcome back, students. Last time we learned chapter triangles and we have done two criteria of congruence of triangles, that was SSS and SAS. Today we will be learning about some more criteria. The next criteria for congruence of triangles is angle side. Angle side means two angles will be given equal and a side will be given equal. Two angles will be taken first and then a side. In triangle ABC and DEF, you can see angle A is equal to angle D, reason given. Angle B is equal to angle E, reason given. And this BC is equal to EF, given. So triangles are congruent by AAS. We have taken an angle, another angle, and then a side. Triangles congruent by AAS. Another ways of seeing this can be, in place of A and B, A and C are given, then this side will be included. Another way is, these two angles, base angles are given equal. These two angles, B and C, are given equal, then this side. But along with this side can also be equal. But this side can never be equal. The side which is included between the equal angles can never be equal if you are supposed to use angle side criteria. Any side adjacent to any of the angles can be equal except the side included between them. This side can also be equal. Here this side can be considered. Here this side can be considered. But the side which is between the two equal angles cannot be considered for angle side. If the side in between is taken, then the axiom which is used is angle side angle. Angle side angle. If the side which is included between the angles is considered, then the axiom is angle side angle. In triangle ABC and DEF, angle A is equal to angle D. Angle B is equal to angle E. But now the side in between them, that is AB, is equal to DE and not this or this side. This is ASA. If the side is coming in between, axiom is angle side angle, and if side is adjacent but not in between, then that is AAS. Another case is, these two angles are there and only this side. There is no choice of any two of these sides, any one of these two sides, but only the side included in between the angles will be taken. This is angle side angle criteria. Next one and last axiom is right hypotenuse side. Right hypotenuse side, R denotes the right angle, hypotenuse, H denotes the hypotenuse, and S denotes the side. Hypotenuse is the side opposite to right angle. Side means any of the two remaining sides can be equal. These are two. This hypotenuse can be used only in right angle triangle. It doesn't mean that only right angle triangle can use it. It can be used in, only right angle triangle can use it. It doesn't mean right angle triangle cannot use any other axiom of angles. It can use AAS, it can use ASA, but right hypotenuse can be used only in right angle. In no other triangle it can be used. Two triangles are there in triangle ABC and DEF. Angle B is equal to angle E, 90 degree each. This AC hypotenuse opposite to 90 degree is equal to DF, opposite to 90 degree, given. And AB is equal to DE, given. So right angle is there, hypotenuse is there, and side is there. So triangles are congruent by RHS. Another way of seeing it can be right angle, hypotenuse, and in place of AB, now BC is equal to EF. These are also congruent by RHS. Let us solve a question related to it. Before going to the question, one term you need to know, because the question includes that term. The term is median. What is a median? A straight line joining the vertex of a triangle to the midpoint of opposite side is called a median. That is, if I draw a line from one of the vertex and it meets on the opposite side on the midpoint. Midpoint means a point which divides the line into two equal parts. That is, this BD is equal to DC. Then this AD is median. Similarly, if I draw a line from B and it meets AC at E such that this AE and EC are equal, then BE is the median. If I draw a line from C and it meets AB at F such that these two are equal, then CF is also the median. You have understood what is median? See the question now. In the given figure, AD is median of triangle ABC. AD is median. First of all, AD is median means it is given that because AD is median, this BD will be equal to DC. BD is equal to DC. Reason, AD is median. Then BM and CN are perpendiculars. BM and CN are perpendicular means these angles will be 90 degree. Drawn from B and C on AD and AD produce. Prove that BM is equal to CN. We have to prove BM is equal to CN. We will prove the triangles containing them congruent, like we did last time also for some questions. And these two sides will be equal by CP, CT, So which triangles contain them? Look for triangles which can be congruent. This triangle side BM is contained in this triangle ABM also and BMD also. But this triangle AB and CN is contained only this triangle CND. Now CND can be congruent to this triangle, though both of them contain 90 degree. These two sides are also equal. And one more equality we can find. So only these two triangles will be considered. Name them in triangle. Over here. In triangle. What is the first triangle? BMD. And triangle. What is the next triangle? BMD we have taken. CND. Triangle CND. What is equal? This angle 90 degree and this angle is also 90 degree. First thing this I can write. Angle. What is the angle? BMD. BMD is equal to angle CND. CND. Reason 90 degree each. Then what else I can write? These two angles are also equal. Reason vertically opposite angles. So angle BDM is equal to angle CDN. Angle BDM is equal to angle CDN. Reason vertically opposite angles. Then two angles we have got. We need a side now. No criteria involves AAA. Either it is SSS or includes two angles and side. This side is equal. BD is equal to DC. Just now we have proved. So BD is equal to CD. Reason AD is median. Or you can write proved above also. BD is equal to CD. We have got three. How we have got? We have got an angle, then an angle and then a side. Side is not in between. So triangle BMD is congruent to triangle CND by AS. Angle, angle and a side. They are congruent. BM is equal to CN. BM was opposite to this vertically opposite angle and CN was also opposite to it, means these are corresponding sides. So BM is equal to CN by CP, CT, C. We have proved. See one more question now. The next question is, in the given figure, two lines AB and CD intersect each other at point O. This is one line, this is another line, such that BC is parallel to CD. These two lines are, BC is parallel to AD, these two lines are parallel, and BC is equal to AD. They are equal also. Show that O is midpoint of line segments AB and CD. We have to show that O is a midpoint. How O will be the midpoint? O is midpoint means if AB is a line and O is a point on it, O will be the midpoint if these two sides are equal. And another line is CD here. O will be the midpoint of CD if these two parts are equal. That is, we have to prove. First write down to make it clear and easy to prove. AO is equal to BO and CO is equal to DO. If we will prove this, this point that O is the midpoint will be proved. That it is dividing them into equal parts. So now look for triangles which contain AO, BO, CO and DO and prove them congruent. Then these sides will be equal by CPCT C. The triangles containing them are AOD and BOC. In AOD and BOC, these two sides are given equal and no other sides we have to prove. So we will look for angles. Are any angles equal? By property of parallel lines, these two angles are equal because they are interior alternate angles, and these two angles are also equal, interior alternate, and these two angles are also equal, vertically opposite. All three angles are equal. We can consider any two angles out of three, and one side is already given. We'll consider two angles and one side, and then we'll prove the triangles congruent. So first name the triangles. In triangle OBC, OBC, and triangle OAD, OAD. What is equal? This angle OBC is equal to angle OAD. Reason? Alternate angles, interior alternate angles. Next, this angle, I am considering these angles. You can take this one also. Angle OCB is equal to angle ODA, again interior alternate angles, and the side which is included between them, that is BC, is equal to AD. Reason? Given. Two angles are taken and the side between them is taken equal, so triangle OBC is congruent to triangle OAD by ASA. Angle, then a side, and then an angle. Angle, then a side, and an angle. They are congruent. And because they are congruent, I can write AO, which was opposite to this angle, is equal to BO, which was opposite to this angle. AO is equal to BO by CPCT C, and opposite to this angle is DO, and opposite to this is CO. So CO is equal to TO by CPCT C. When these parts are equal, I can write O is, therefore O is midpoint of AB and CD. And in with this line, because this was what was to be proved. Now see, if you are considering these angles and any one of these two, then the criteria used will be AAS and not ASA. Be careful with that. So with this you can do second exercise. I'll discuss some more questions of this exercise in next video. Till then you try these questions.